Brady, are you outside?
Okay, we're going to sketch the region bounded by the graphs of the algebraic functions and find the area of the region. So what I want to do is sketch the region first. So I'm going to take this function here, and we know it's a parabola. We know it's opening up because it has a positive x squared. And the easiest way to graph it, I'd probably find its vertex first, and you can just find its derivative real quick, which is 2x plus 2. And we know it's a parabola opening up, so then when I find its vertex, it's at -1. So then when I sketch its graph, I'm going to go over to -1, and then I plug -1 back into the original function, which happens to be -1 squared is 1, plus 2 times -1 is 1 minus 2 is -1, plus 1 is 0. So the vertex actually happens to be on the x-axis. So this is what my parabola looks like. You could also say the parabola crosses the y-axis at 1. Right here, we'll say this is 1. All right, then the next graph, g of x equals 3x plus 3, I'll go ahead and just plot my y-intercept of 3. And then I'll do my slope of down 3, left 1, down 3, left 1. And I can also go up 3, 1, 2, 3, right 1. Then I sketch the line through those points. And so let me do that. Oops, try that again. That's better. And then the area of the region enclosed by these two curves, you got to find the region that's closed off, would be this piece between the parabola and the line itself. Okay? So there's the area of the region that the directions want us to sketch, and now I want to find the area of that region. So I'm going to obviously do this with the x-axis. So when I find the area under the curve, and just kind of follow this, the reason it ends up being top minus bottom is because if I take the area under the line, I'm going to get all this stuff below the line. So just imagine all this stuff below the line, all the area below the line. And then if I do the area under the parabola, that would be this blue stuff. And if I take the red area and subtract off the blue area, I'm just going to end up with that black part, which is the area enclosed by the region. So we're going to take the top function minus the bottom function. It's always the way we do it. So it's going to be the area, and the top function is the line, which was g of x. So I'm going to go g of x minus the bottom function, which is f of x dx. The other thing I need to locate are the limits of integration. And since everything is in terms of x, my limits have to be in terms of x. So I'm going to have to go from this value to this value. I know this one's -1, but if you don't know what those values are, all you have to do is take the two equations and set them equal to each other since they both equal y. g of x and f of x are both y's. So I'm going to have x squared plus 2x plus 1 is equal to 3x plus 3. When I solve and set it equal to 0, I'm going to have x squared minus x minus 2 equals 0. So I'm going to end up with x plus 1, x minus 2 equals 0. So I end up with x equals -1, which is the one we already knew. And then the other one is x equals 2. So it's going to be bounded from this value, which is -1, up to this value, which is 2, positive 2. So I'm going to bound it from -1 to 2. Now I'm going to go ahead and plug my equations in. The reason I did it symbolically first is because on the AP exam, if you've got a calculator, all you got to do is represent your area under the curve. You can label the functions based on the labels given, and then you're just typing it on the calculator to get the work. So it's going to be the area from -1 to 2 of g of x, which is 3x plus 3, minus x squared plus 2x plus 1 dx. You only need a dx once because this is one integral. And I'm going to distribute my negative. I'm going to rewrite the integral first before I evaluate the integral. So it's going to end up being a -x squared. Distribute the negative here. That's going to be a minus 2x plus 3x is a plus x. And then we'll have a 3 minus 1, which distribute the negative here, ends up being a positive 2 dx, which is very similar to this equation up here if you look at it. That's because of where they intersect in the first place. This ends up being -1/3 x to the third plus 1/2 x squared using the simple power rule plus 2x. Really, -1 to 3. Then evaluate with FTC, fundamental theorem of calculus. It's 1 to 2. I need to go back and change those. A little birdie told me that. It's name's Nick Kalina.
Big Birdie.
So, yeah, Big Bird, I guess. So negative 1 to 2, so it's going to be negative 1/3. 2 cubed would be 8. Plus, I'm just going to go ahead and write that as negative 8/3. Then we're going to have 2 squared there, which is 4 times a half, which is 2. Plus 2 times 2 is 4. Then we're going to go minus. Plug in a negative 1. Negative 1 cubed is going to be negative 1 times negative 1/3 is positive 1/3. Negative 1 squared is 1. That'll be plus 1/2. And then it'll be minus 2. And then to simplify this, finish it, I'm going to go ahead and these have a common denominator. So I'm going to have negative 8/3 minus 1/3 is negative 9/3, which is negative 3. So those are gone. We can have, let's see, 2 plus 4 is 6. So we have plus 6 minus 1/2 plus 2. So there's 3, there's 5, and then 5 minus 1/2 is 4.5 or 9/2. There you go.
Now I don't have to watch that video.
I know. That was well